Calculate the mass of PbSO4, which is produced when 30.0 milliliters of 0.750 molar PbNO32 is mixed with an excess of sulfuric acid. Okay, so we have a balanced chemical equation here that's going to allow us to convert lead nitrate into lead sulfate. Okay, so calculate the mass. So the thing that we want to know in the end is question mark grams of PbSO4. The thing that we know is we have 30 milliliters of PbNO3. Okay, and we are also told that it is 0.750 molar. So that's moles of PbNO3 for every 1 liter of PbNO3. Okay, it's mixed with an excess of sulfuric acid, so I don't need to worry about this. PbNO3 to PbSO4. All right, so I'm given milliliters, I'm given volume of a solution, and I want grams of PbSO4. So I've just developed a train map in order to get through Moletown. So right here we have a known volume of liquid, and we're going to convert by using molarity in order to get to quote-unquote Moletown. The mole ratio, or the number of moles of PbNO3 compared to the number of moles of PbSO4. And so I can use molarity in which to do that. So my very first conversion factor is in liters, but I have milliliters. So I can't match up those units yet, but I can go 1 liter of PbNO3 is equal to 1,000 milliliters of PbNO3. Let's see, I'd like milliliters to be on the bottom. Milliliters of PbNO3. And I would like liters of PbNO3 to be in the numerator. The reason I chose this way is so that I could cancel milliliters of PbNO3 with milliliters of PbNO3, leaving me in the units liters. Now I can come back and use this conversion factor. 1 liter of PbNO3 will give me 0.750 moles of PbNO3 too. And I do that so that I can cancel the liters of PbNO3 with the liters of PbNO3, and now I'm in moles. And now it's time to go to Moletown. If we take a look at my train map, I've taken the volume that I know, gone through molarity in order to get to Moletown, my mole ratio that comes from my balanced chemical equation. So I'm going to say that 1 mole of PbNO3 gives me 1 mole of Pb, now this time SO4. let's see, I have moles PbNO3, so I'm going to put 1 mole of PbNO3 and 1 mole of PbSO4. So now I've turned the components into difference. So I can cross out moles of PbNO3 with moles of PbNO3 too. Now I'm in moles of PbSO4. I'm one step closer. All right, so I'm in moles, but I want grams. So if I go back to my train map, I'm in Mole Town, and now I want grams. So I'm going to need the molecular mass in order to get unknown mass. Okay? So now I just need to figure out what PbSO4, what the molecular mass of PbSO4 is. And I can do that by basically taking the atomic mass of each one of the elements, multiplying by the number of atoms are in PbSO4 to get that portion of the molecular mass. So I have 1 atom of lead, I have 1 atom of sulfur, but I have 4 atoms of oxygen in PbSO4. So grand total is 103.25 grams per mole. So I can add that to my list of conversion factors. So 1 mole of PbSO4 is 303.25 grams of PbSO4. I need 1 more field goal. This is a long one, so I'm going to take away 3, I'm going to add 4. And to 4, let's see, I want 1 mole of PbSO4 to be in the denominator, and I want 303.25 grams of PbSO4. And I do that so that now I can cancel out moles of PbSO4 with moles of PbSO4. And at this point, I'm in the units that I want. That's good. So I'm going to take the number 30. I'm going to multiply by 1, which is right here. I'm going to multiply by 0.750. I'm going to multiply by 1. I'm going to multiply by 303.25. All of that is going to be over the different math problem of 1,000 times 1 times 1 times 1. When I simplify the top, I get 6823.125. When I simplify the bottom, I get 1,000. When I go ahead and do that math, I get 6.823125 grams PbSO4, which is pretty good. But if I needed to significant figure, I have 3 sig figs here, and then I was also given this number, which has 3 sig figs. So my answer is going to have 3 significant figures. Just to make it nice, clean, and pretty, it's going to be 6.8. The 2 is significant. The 3 is not significant, but it might be important. It's not in this case. It does not round the 2. Grams of PbSO4.